Everybody, in this video, I'm going to go through lesson 5.6, use algebra to describe geometry. So we're going to talk about all of the different types of transformations and their coordinate rules here in this lesson. And I want to start by talking about, we'll start with blue, coordinate reflections. So how do I reflect in the coordinate plane? So if you would like to reflect across the x-axis, and I'm going to give myself a little bit more space here off to the side so I can draw a little picture. So please remind yourself the x-axis is your horizontal axis. So your point that was up here maybe is going to reflect down below. Oops. Sorry if you hear my cat. So reflecting across the x-axis turns the point x comma y. The height has changed. So it's x comma negative y. Similarly, if we are going to reflect across the y-axis, the y-axis is our vertical axis. So a point that is over here might reflect over to the opposite side. So your point x comma y, now the x coordinates are changing, becoming opposite. So negative x comma y is the coordinate mapping rule that could be used. So those are kind of our basic reflections. Now we can also talk about reflections across diagonal lines. So we can reflect across the line y equals x, which is a diagonal line that has a slope of 1 and goes through the origin. And if you think about, you have a point on this side and it would reflect over to this side on the opposite side. I don't like the arrow. There we go. So the mapping rule for this, your point x comma y, it is reflecting, so it is going to become the point y comma x. If you reflect over the line y equals x, you are just reflecting the point y comma x. If you want to reflect across the line y equals negative x, this is kind of opposite thinking now. We now have this line y equals negative x. So if you have a point up here, it's now going to reflect down below. So the mapping rule for this is x comma y, you're a point. It's going to flip, right? It's going to reflect y comma x, but they're also both going to become negative. So the mapping rule for this is x comma y becomes negative y comma negative x. Those values flip and become negative. If it's just the line y equals x, they just flip because it's a reflection. Let's talk now about coordinate rotations. And these rotations here that we're describing, they are all about the origin. So that's important to note. So we could rotate the figure 180 degrees, either direction. And your point, x comma y, is going to rotate around kind of twice, and the signs are going to flip, and it's going to become the point negative x comma negative y. So when you rotate 180 degrees, the point essentially stays the same, the signs just flip. The other ones are a little bit different. So imagine here we're rotating 180 degrees. That is rotating 2/4 of a circle or half of a circle either direction. So what if we are rotating 90 degrees clockwise? That means we are rotating a quarter of a circle the way a clock spins. So your point, x comma y, is going to become the point y comma negative x. So essentially what's happening is it's rotating around the quadrants. So when it does this, the values will flip-flop and one will become negative. So if we're going clockwise, they will flip-flop and your x will become negative, which is really in the y position. If we are going to rotate 90 degrees counter clockwise, that's now going the opposite direction, a quarter of a circle. And the point x comma y, it's going to flip, but now the y becomes negative. It'll be negative y comma x. So notice in both of these, whether you're going clockwise or counterclockwise, the y and x will rotate positions here. If you're going 90 degrees clockwise, your x is going to become negative, and then counterclockwise, your y. And this kind of takes practice working with. All right, next I want to talk about coordinate translations. So there are lots of ways you can translate a shape. So, let's start with red here. We can translate or shift h units to the right. So you can take your graph and shift it h units to the right. And the mapping for this, your point x comma y, you are shifting left or right, meaning, or if you're shifting to the right, you're affecting your x values here. So this is really x plus the number of units that you are shifting, h comma y. Now, if you are translating h units to the left, now you're going the opposite direction, h units. So you are going to subtract h. So your point x comma y is now going to be x minus h comma y. So if you're going to the right, you add h, and if you're going to the left, you subtract. All right, now what if we're going up or down? So let's start with if you are translating. Oh, I didn't realize I misspelled this word. Sorry about that. What if you are translating K? We're going to switch letters because you could go left, right, you could go horizontally, and you could go vertically. So translate K units up. The mapping for this, your point x comma y, you are going up K units. So you are going to add K to y now. So x comma y plus K, because your y values are what's being affected. Next, let's talk about if you were going to translate your figure K units down. So the mapping for this, your point x, y, is going to map to x is going to stay the same, but now we're going down K units. So we're going to subtract K from our y coordinate. So x comma y minus K. Please note that you could, do a couple translations at once. So if we are going to translate h units horizontally, meaning to the left or to the right, and K units vertically, meaning up or down, The mapping for this, you would have something happening to the x and the y coordinates. So this would be the point x comma y. And actually, let me write this down below, just so it looks a little bit better. The point x comma y. Your x value would move some amount, some h units, and you would either add it or subtract it. So it'd be x plus or minus h, comma, y plus or minus k, because you would add or subtract a certain amount of units. You would be going left or right, and then up or down. All right, and then please note with this, you can always talk about the translation vector that's occurring. So if you go up h units, well, that would be k, because k is vertical. So let's start with, if you go to maybe the right h units, and then you go down k, the translation vector that would represent this would be just the diagonal line that essentially has the slope negative k over h, right? Because it's always rise over run. And then we write this translation vector. You can write this in a couple different ways. Our geometry book I've seen, or the writing oftentimes writes it with kind of like these little, I don't know what you want to call those. They almost look like parts of a triangle. And the vector would be plus or minus h, comma, plus or minus k, meaning you go to the left or to the right, h units, and then you go up or down, k units. All right, last transformation that we have not talked about, and that is dilations. I meant to write coordinate dilations, so I'm just going to shift it over now. So coordinate dilations, they really, and this is, I forgot to put it, here we go. They have their center of dilation at the origin. At least the ones we're going to be looking at here. So what are the coordinate dilations? If you have your point x comma y, you can dilate it by some scale factor k by multiplying both x and y by k. So k times x comma k times y means that this is dilating by some scale factor. Now, if k is some number bigger than 1, then this shape is expanding, right? Or enlarging. It's getting bigger. But if k, if k is less than 1, then it's shrinking, right? Or it's condensing. All right, let's look at some examples. Please also remember that dilations are not rigid. Horrible stars, but not a rigid motion, meaning the congruence is not held from the pre-image to the image. After the transformation, those shapes are not congruent. All right, so first example, and I do want you to actually write down the problem so you know when you're looking back on this later what the work is for. What is the image of the point 3, -5 after a translation 5 units right. And up 4 units. So we have this point 3, -5. And this is like our pre-image. And we want to translate it 5 units right. So if we're going to go 5 units right, that's going to take our point x comma y, and we are going to add 5 onto x. So x plus 5 comma y. This will go to the right 5 units. And then we want to go up 4 units. So to do that, the point x comma y, now we're affecting the y values. So this would be x comma y plus 4. And this tells me then that we are going to go up 4 units. So we have to do both of these together. So really, we're adding on 5 to x and we're adding on 4 to y. So this point, 3 comma -5, we have to transform it and add 5 onto x and add 4 onto y. So let's see what happens. When I take the original x value 3 and I add on 5, that gives me a new x coordinate of 8. And now looking at the y coordinate, if I add on, or if I take -5 and add on 4, -5 plus 4 is -1. So our pre-image 3 -5 would map to the image of 8 -1. All right. Number 2. What is the image of -2 comma 3 after a reflection over y equals x, followed by a translation down 2 units. All right. So we have our image, the original point, -2 comma 3, or not our image, sorry. This is the pre-image. Oops. It has not been translated yet. And then we want to reflect it, right? So we want to reflect it over the line y equals x. So the rules for that, let's go back up because we've talked about lots of things now, and it's okay to go back to our notes. So reflecting over the line y equals x means we're going to take our point and I'm going to flip the y and the x. So to reflect this point, again, x comma y means I'm going to flip the points values. So it would be y comma x. So -2 comma 3 reflected over the line y equals x would be 3 comma -2. And then we want to translate down 2 units. And we talked about that kind of in the last example. We're going to be affecting the y values here. So the point x comma y, I'm going to subtract 2 from my y value. So it'd be x comma y minus 2. So nothing's changing with our 3. And then I have -2 minus 2. So our pre-image of -2 comma 3 will map to now our image, which is 3 comma, and then simplifying -2 minus 2 gives us -4. All right, number 3. Point A, which is 4 comma negative 1, is rotated 270 degrees clockwise to produce A prime. What are the coordinates? Coordinates. Ah, I knew I was going to do that. Of A prime. So let's think about what it's asking us to do here. And I kind of would like to draw a little diagram. So this is our coordinate plane, x, comma, y. And this is the point for negative 1. So here's the negatives, here's the positives, positives, and negatives. So 4, negative 1 would be over here. And I want to take it and I want to rotate it 270 degrees clockwise. And remember, 270 degrees, that's 3/4 of a circle. So you could look at this as rotating it 180 degrees and then an additional 90 degrees clockwise. Or 270 degrees clockwise. And there we go, is the same thing, and I'm going to abbreviate here, clockwise, is the same as 90 degrees counterclockwise. And whether you took the work to apply the rules to rotate it 180 degrees and then another 90 degrees clockwise, or you just use the rule to rotate 90 degrees counterclockwise, it's going to have the same effect. So point A prime, or sorry, A is the point for negative 1. And now let's remember what the rules are to rotate 90 degrees counterclockwise. Boop, boop, boop. 90 degrees counter, x comma y, they're going to flip, and it'll be negative y comma x. So let's write that down. X comma y is going to flip. It's going to be negative y comma x. And this is the same thing as rotating 90 degrees counter clockwise. So 4, negative 1 is now going to become, we're going to flip our x and our y, and the first value, the y, is going to change signs. So it's really 1 comma 4. And this is our new point A prime. And think about it, if I plot that point 1 comma 4, that would be right about where my arrows are, wouldn't it? So rotations are kind of tricky, but they are, I think, a lot of fun. We're gonna do one more. 4. And this has the diagram, which is available in the lesson notes. Please take this moment to print it out or recreate it for, what you can. The figure is rotated 180 degrees clockwise, then dilated and origin is the center of dilation. It's dilated with a scale factor of 1/2. What are the coordinates? Of the image of E, sorry. because E is in the pre-image. So what are the coordinates of the image of E after these transformations? So here is the diagram. I need to make this just a little bit bigger so I can see it. And I notice here we have this point E. So in the pre-image, E is the point -6, comma 2. So if I want to just perform the transformations to this point, I certainly can do that. I don't have to do it to the whole point. So first, it's going to rotate 180 degrees clockwise, which I could, just draw that with this one point, or I can apply the rule, right? And to rotate 180 degrees either direction, your point x comma y is going to become -x comma -y. And that's because it's rotated 90 degrees clockwise twice, or 90 degrees counterclockwise twice. So this point, -6, 2, both of those signs are going to flip. So it's going to be +6, comma, -2. So this is just rotated 180 degrees. So let's see, that's going to be at 6, -2 here. And now we need to dilate it by a scale factor of 1/2, which means we're going to really multiply by 1/2. So I'm going to multiply both my x and my y by 1/2. So it's going to be 1/2 times x times, or comma, 1/2 times y. So this pre-image E, we have rotated it, and now we are going to dilate it by multiplying both the x and the y by 1/2. So 1/2 times 6, comma, 1/2 times -2 gives us that our image has the coordinates 1/2 times 6 is 3, and 1/2 times -2 is -1. So 3, -1. That is our image after both translations. Please let me know what questions you have, and I look forward to seeing you in class.